Right, so it says here, let's choose sodium as a metal and chlorine as a nonmetal. Right, we're going to see this example quite a bit. And so here you see chlorine atoms have a strong attraction for electrons, right? These blue ones. And so under certain circumstances, the chlorine atom, the blue one, will be able to take one electron from a sodium atom. Remember, if it wants it more, it means it is electronegative. So this little chlorine atom is an electronegative atom, more electronegative than the sodium. So it means it's an electron hog, right? It wants to hog up the electrons. And so an electron is ripped from the sodium atom, this Na atom, turning it into a positively charged sodium ion, right? So again, it's losing a negative electron, so it's going to become overall positive because it's going to have more positive things than negative things. So the chlorine atom gains the electron and it's going to become negatively charged. It's going to be called chloride once it gets that, once it becomes negative. That part's not so important for us, but just remember, it will become a negative ion because it's going to gain an electron. So there you see, it lost that electron becoming positive. This one gained an electron becoming negative. The two atoms are now oppositely charged and called ions. A positive ion is a cation, a negative ion is called an anion, and now positive and negative will attract. All right, and there they go, attracting towards each other because they have opposite charges. So the two ions are held together by the attraction between the opposite charges, right? So that force of a positive and a negative force coming together, that's what's holding these chlorine and sodium ions together. This is what an ionic bond is, right? So it's just a simplification, but let's take a look at this again. Just something that resembles more the way it happens in the real world, right? So chlorine is typically a gas, and those atoms are found in pairs. So you usually find two of them together, right? The sodium is typically a solid metal, but when it's heated, it vaporizes, separating the individual sodium atoms, right? So you see here they're moving, right? There's that kinetic energy we talked about. But when it's heated, it eventually vaporizes, and these sodium ions separate, or sodium atoms separate. So each atom in the Cl2 molecule, remember Cl2 because there's two of them together in this molecule, it needs one sodium atom to react with. So that's what's going to happen here. And you see when that happened, all of a sudden the positive and the negatives connected with each other, they bonded with each other, and the end result is that Na plus and an Na plus ion is formed and a Cl minus ion is formed, and they bond with each other. Right? But remember what opposite charges do, right? They attract. So look at this. The positive ions attract with any negative ions, just as the negative ions are going to attract with any positive ions. So look at this right here. See, so now they've attracted with each other, the plus with the minus, this plus with the minus, and when there are more of them together, look what happens. So all the positives are connecting with all the negatives, and all the negatives with the positives, right? And that's how they are throughout this molecule. And so this continues in 3 dimensions. So when you spin this, you'll see that there's always a red touching a blue, right? Always a positive touching a negative. And so we drag this below to see what this might look like. And again, they're just every negative is connected to a positive. There aren't any distinct molecules, right? Instead of calling this compound a molecule, we'll call it an ionic crystal just because it's very crystal structured shape and they're made of ions, right? And we won't have to worry about writing the ionic compounds.